Welcome back. The question is for non-negative integers s and r, let s r is equal to s factorial divided by r factorial of s minus r for if it is r is less than or equal to s and if r is greater than s. For positive integers m and n, let g of m comma n is summation of m plus 0 to m plus n, that is f of m comma n comma p divided by n plus p by p. For any non-negative integer, p is given as summation of m I n plus I by p or p plus n and p minus I. So which of the following statement is true about these equations? That m and n is equal to n and m for all positive integers m and n, n plus 1 is equal to m plus 1 and n for all positive integers m and n, 2n and 2m is equal to 2 of n, m and n for all positive integers of m and n, or 2n and 2m is equal to m comma n whole square for all positive integers m and n. So for this solution, given that this question, we can take permutation combinations and we substitute the combination of mci dot n plus I into cp dot n plus p into c of p minus 1, where n by r is equal to ncr. So by substituting these values, we get that n plus p of c into p is taking common, then we get m of c0 dot ncp plus mc1 ncp minus 1 plus so on into mcn into ncpa minus m. So coefficient of xp in the 1 plus x whole power n of x plus 1 whole power m is given. So from this we get that gm comma n is also, we can take a common, that is 2 power m plus n, which is equal to 2 power n plus 1. So we get g of 2m comma 2n is equal to 2 into 2 square of m plus n, which gives g of m comma n whole square. So g of m comma n plus 1 will be 2 into m plus n plus 1, which gives 2 power of m plus 1 plus n, which gives g of m plus 1 comma n.